This is Mr. Martin. These are the video notes for lesson 4.6 for Geometry Advanced. We're going to be talking about corresponding parts of congruent triangles, and we usually abbreviate this CPCTC for corresponding parts of congruent triangles are congruent. Okay? Corresponding parts of congruent triangles are congruent. Okay, so we take the first letter of each word. Now, the most important thing to take away from this lesson today is that we cannot use this theorem until after we prove triangles congruent. Okay, so prove triangles congruent first. Okay, so CPCTC will always follow triangles congruent in your proof. So let's go ahead and take a look at these. I've pre-filled out the given information, so if you want to pause the video to get caught up throughout, feel free to do that. So we've got EF, and we've got GH, and we've got GF, and we've got EH. And again, in order to get angle H congruent to angle F, because we know if triangles are congruent, that all 6 parts of one triangle are congruent to all 6 parts of the other triangle. So when we're proving that the triangles are congruent, we only need to get 3 pieces of information. So either the 3 pair of sides, 2 pair of sides and an included angle, 2 angles and an included side, or 2 angles and a non-included side. So we have 4 methods to prove triangles congruent. Each of those methods only needs 3 pieces of information. So once we get the triangles congruent, what does that mean about the other 3 pieces of information? Well, it means that the other 3 pieces of information will be congruent as well. The corresponding parts of the congruent triangles, once we get them congruent, will also be congruent. So let's go ahead and get these triangles congruent. So I've got step 3. I can see that I can use this reflexive side down the middle. So I've got that GE is congruent to, and in this case it's going to be EG because I've got to rotate one triangle around to get it on top of the other. And that's the reflexive property. And then once I have that, I've got enough information to prove that triangle GHE is congruent to triangle, so GHE, so I need to go EFG for the other triangle to make sure it's in a corresponding order. If you're not sure what I mean about that, make sure that you check with me so that you're not losing a point every time you name them in a non-corresponding order. And our method is from side, 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 and we got our 3 pair of sides from steps 1, 2, and 3. So I use these 3 pair of parts, 1, 2, 3, these 3 pair of parts to get the triangles congruent. So since the 3 pair of sides are congruent, I know that the 3 pair of angles will also be congruent, and angle H and angle F are a pair of those corresponding parts. So we would say angle F congruent to angle H because corresponding parts of congruent triangles are congruent. Okay, you'll always have triangles congruent followed by CPCTC. You have to have triangles congruent first before you use CPCTC. Alright, as usual, pause the video and write down those questions, or pause the video and call me over if we're watching in class. Alright, example number 2. Again, pause if you need to get the given written down. I've got SP congruent to TP, and I've got that GF bisects angle SPT. That should be PQ. So let's go ahead and fix that. PQ bisects angle SPT. So if it bisects the angle, then I know I'm going to put a 1 here and a 2 here just to make it easier for us to name those angles, and you can do that in pictures anytime as well. So now, since GF bisects angle SPT, I know that angle 1 is congruent to angle 2. And the reason that I know that is by the definition of bisect. Okay, if a segment bisects an angle, then it divides it into two congruent angles. So now I've got that these angles here are congruent. And again, I've got my reflexive side down the middle, and this time I just have to fold the picture in half to get the triangles to line up. So it would be PQ congruent to PQ, and that's my reflexive property. And this gives me enough to say that the triangles are congruent. So I've got triangle SPQ congruent to triangle TPQ. And my reason there would be side, angle, side. And the parts are from steps 1, 3, and 4. So again, I have 3 pair of parts congruent already, a pair of sides, a pair of angles, and another pair of sides. So the remaining parts, the remaining pair of sides, and the remaining 2 pair of angles would also be congruent. And SQ and TQ are a pair of those corresponding parts. So those would be congruent by CPCTC. So again, I'm going to repeat. We only use this after we have triangles congruent. Okay, so you have triangles congruent, then you can use CPCTC. So make sure you're asking me questions. Make sure you're pausing the video and writing down those questions you're asking me. Moving on to example 3. Again, pause if you need to write down the given. And you'll notice I separated the given into 2. Since C bisects both BD and AE, I just wrote it as 2. And we know that if it bisects it, it divides it into 2 congruent parts. So I have this congruent to this. And that's an E up here if that didn't show up on your paper. And let's get that down. So I've got BC congruent to DC. And that's definition of bisect again. This time we're bisecting a segment. And I've also got that AC is congruent to EC. AC congruent to EC. And that's same as 3. If you want to write definition of bisect again, you can. And now we've got these vertical angles. Again, I'm going to put a 1 here and a 2 here just to make it easier to name those angles. And again, if you want to do that, you can. So I've got step 5, angle 1 congruent to angle 2, and that's because they are vertical angles, and vertical angles are congruent. Okay, and then we can have enough information to prove the triangles are congruent. So triangle ABC is congruent to triangle. So if I go ABC, I need to go EDC. EDC. Make sure you ask if you're not sure about that corresponding order. And we've got side. The angle is in between the two sides and another side. So side, angle, side. And I've got steps 3, 4, and 5. So now that I have these 2 triangles congruent, I know that the other pair of corresponding sides, AB and ED, also have to be congruent by CPCTC. Corresponding parts of congruent triangles are congruent. Alright, pause as needed. Moving on to example 4. Again, pause if you need to write down the given information. I've got AC congruent to BC, and I know that M is the midpoint, so that I know that AM and BM will be congruent. So let's go ahead and write that. AM congruent to BM, and that's definition of midpoint. We know that a midpoint divides a segment into 2 congruent segments. And we've also got this reflexive side here. So I've got CM congruent to CM, and that's our reflexive property. Make sure you write out the whole thing, reflexive property. You can abbreviate the word property if you want. And now I've got enough to say that triangle ACM is congruent to triangle BCM. and that's going to be by side, side, side. So now that I proved that the 3 pair of sides are going to be congruent, I know that the other 3 pair of angles are going to be congruent, and this is one of those pairs of angles. So I've got angle ACM congruent to angle BCM. Be careful, because these two statements, they look very similar, but in step 5 we're proving the triangles are congruent, and step 6 we're proving just the angles are congruent. Okay, let's put our steps here in number 5. So that's 1, 3, and 4. And then once the triangles are congruent, I know all the other corresponding parts are congruent. Corresponding parts of congruent triangles are congruent, or CPCTC. Okay, so that's really going to be the end of this video. I'm going to have the worked out solutions pop up for you for the other 4 examples, but I would encourage you to go ahead and work those out. And then I'll scroll through in the video. And again, when that solution gets up, if you want to check it with yours, go ahead and pause the video. And again, make sure you ask me any questions, and we'll see you next time. Okay, so here's the solution to the first additional example, the more practice. If you want to go ahead and check yours, go ahead and pause the video now. And again, notice how I have triangles congruent, then CPCTC, so pause as needed. Here's the solution for number 2. Pause if you need to. Here's the solution for number 3. And here's the solution for number 4. This could possibly be our longest proof yet. Notice here the perpendicular tells us that we have right angles. That's the definition of perpendicular. If segments are perpendicular, they form right angles. Then once we have the right angles, we know that they're congruent. So make sure you do that anytime you have perpendicular. And again, triangles congruent, then CPCTC. So let me know if you have any questions about these, and we'll see you in the next video.